All right, so today we're looking at introduction of solving one-step equations by adding, subtracting, and dividing. Okay, so that's kind of what our method's going to be. The things that we're going to cover here for the next couple days. So today we're getting an intro of what that looks like. Okay, so some key terms to figure out and know. All right, as we're going through here and checking them out. All right, the first one is a variable. Okay. So a variable is a letter or symbol used to represent a value that can change, okay? So we had that in our warm-up. What is the one that we typically use? X, yeah. Typically 9 times out of 10 you see an X. Can I use a Z? Can I use an A? Can I use a smiley face? Yeah. What does it say? Letter or symbol. It really doesn't matter, guys. There's a million different things that you can use, okay? Those are just some examples of anything that you could use. All right? Next thing is a constant. Again, this is straight from the warm-up. A constant is a value that doesn't change. So, in other words, it is a number. And it is a number by itself. All right? So, it's not going to be a 4x or a 4y or a 4 smiley face. It's going to be just a 4. Or it might be just a negative 10. It might be a positive 2.75. It is any number. Any number that can be positive or negative. It can actually even be 0, even though it has no value. All right, that would be a constant. Constant can be 0, where it adds no change. All right. Next one. A numerical expression. A numerical expression contains only constants and operations. Okay? So what term did you not see there? No. As in from the two that we did before. Okay, so let me narrow that down. What I meant by that, numerical expression, it contains only constants and operations. What is not there? A variable. Okay? A variable is not there. So a numerical expression is something like this. 2 plus 4. I'm going to give you a couple different examples. Okay? Another one could be 3 minus 1. A third one could be 5 times 2. And a last one could be 9 divided by 3. Those are all examples of numerical expressions. They are just constants and mathematical operations. Now, I gave you 4 examples there because some of you might have forgotten how many mathematical operations are there. 4. Addition, subtraction, multiplication, and division. Okay? All of those are there for you. All right. Then the last term we're going to look at is an algebraic expression. Okay. This is coordinate algebra. This is where we're going. This is where a lot of our stuff is going to happen at. All right. An algebraic expression may contain variables, constants, and operations. Not going to give you as many examples, but I'll show you here. You could have 2x plus 5. That's an algebraic expression. You could have 3y divided by 5. That is another example. You could have 8x. That is another example. Okay? And then just one final example. I guess I'll go ahead and make it complete. You could have 9 minus 6z. Okay? Those are 3 examples of algebraic expressions. Okay? How are we feeling? Good. That's what I like to hear. All right. Now, This is something that we kind of already talked about, all right? The four operations, you have addition, and I'll go ahead and label them. So you've got addition. You've got subtraction. You've got multiplication. And then you have division. Okay? Now, here's the big thing for today, all right? Is we're going to look at writing expressions using words, and then we're going to look at using words to write expressions. So we're going to kind of go back and forth. So this is some of the key words that you can use to describe the four operations, okay? So the first one you have addition, okay? Other ways you can talk about addition, you could say plus. You could say the sum of two things. Or you could say something was increased by. Those are all forms of addition. All right? Subtraction is very similar. Okay? With subtraction, you could say minus. You could say the difference. Okay? Now, I'm going to go ahead and tell you, underline the difference. Okay? Okay? And then underline the difference and circle less than. Okay? Because less than is the one that gets tricky, and we'll see that through some examples. So I just want you to remember that. If we talk about something being less than, it gets a little tricky. All right? Now, multiplication, you could say times. You can say the product of. Or you could say equal groups of. Those are all forms of multiplication. Now, these aren't the only ones. There's other things you could say there. Okay? Like you could say the word multiply if you wanted to. All right, and then division, you could say divided by or quotient. Okay? Do y'all know what a quotient is? Yeah, it's the answer when you divide something. That's called your quotient. All right, so those are all key words of kind of that we're going to use going forward. Okay? So let's take a look right here at the next page. All right, it's got example 1, and it says translating from algebra to words. So they want you to give 2 ways to write each algebraic expression in words. Okay? So if we look at letter A, it says 9 plus R. Okay? Well, one way you can write that is simply 9 plus R. Okay? Now, what I'm going to do is I'm going to give 1 for each type. Okay? And then I'm going to give y'all a few seconds to go through and try and come up with a second. All right? Letter B, you have Q minus 3. Do you want me to give you an easy one here or a harder one here?
Hard one.
Harder one. Okay? So what letter or what words did I tell you to circle on the last one? Underline difference, circle less than. Less than is the harder one because you have to change the order. So if you wanted to write this, you would say 3 less than, that's a Q. 3 less than Q. That really means Q minus 3. So when you use the word less than, the order of whatever it is has to switch. Okay? That's the big thing there. All right. C. What could I say? 7 times M. And then the last one, I will do the hard one for you. You would say the quotient of J and 6. Because that just means J divided by 6. Okay? All right, so what I'm going to do right here is I'm going to give y'all 3 minutes. 3 minutes on your own. If you want to chat with somebody directly next to you, feel free to, and figure out the second example for these. Ready, set, go. perfect. 9 added to R. That is 100% correct. Okay? Ender, you got another way to do Q minus 3? Say back to me what I just said. Say Q minus 3. Q minus 3, perfect. That's exactly. Okay? You could say exactly that. We went the hard route the first time saying 3 less than Q. You can simply say, hey, it's Q minus 3. Okay? Let's see. Who do I want to pick on next? Gavin, did you get another one for C?
I don't know how to use product.
Yeah, that's, you know what you could really do? You're 100% correct. If you wanted to, you could just say product of 7 and M. Okay. Brock, what'd you say for D? J divided by 6. That is absolutely correct. So guys, it's not a big deal. Now, I'm generally not going to ask you to do like multiple ones like this. If you see one, you can just go through and do that. Every now and then I will, just to make sure that you're paying attention and you know multiple ways to do it. Okay? But odds are, if you can do some of these like this, you'll be absolutely okay. Now, on to the next slide. These are specific examples. So we're going to work through all of these together for now, and I'll let you try some later on. Okay? But let's look at example 2. John types 62 words per minute. Write an expression for the number of words he types in M minutes. Okay? So here's where you got to think about things. Okay? And here's where you're going to start noticing key words. All right? So right here it says there's 62 words per minute. Okay? So let me ask you, just thinking through that, if I were to type for 1 minute, how many words would I get? 62. Now, I'm going to ask you a challenge question here. And if you want to answer it, answer it. How many words would I type if I typed for 2 minutes? Not 124. No, you're right. I'm sorry. You were right. 124. I did bad math. 124. That is absolutely correct. Okay? How'd you do that, Brock? 62 times 2. Huh. So how do you think I figure out how many there were if there were 3 minutes? 62 times 3. You are absolutely correct. So what you just did right there was you came up with the equation we needed. How would you express that he was doing M minutes? Well, it would be 62 times however many minutes, which would be 62M. Now, the key word, per. Generally, whenever you see something per minute, per second, per hour, per day, it's going to end up with some kind of multiplication. Okay? That's a key word when you're looking at word problems in algebra. All right? Let's take a look at example 3. It says, Roberto is 4 years older than Emily, who is Y years old. Write an expression for Roberto's age. Okay? So, here's what you got to start with. You know he is what? 4 years older. He is 4 years older. Well, if you're generally 4 years older than somebody, what does that mean you have to do to their age? Add. Add would be the correct one. I am 4 years older than y'all. That means whatever y'all's age is, I'd have to add to it. Well, do we know how old Emily is? No, but we do know it's represented with a Y. So, to write that expression, you would have to take Emily's age, which is Y, and add to it 4. You are correct. All right. And then the last one here. Joey earns $5 for each car he washes. Write an expression for the number of cars Joey must wash to earn D dollars. Okay, now, this one is a step further. Okay? Why? Well, it deals with each car. That is absolutely correct. But what are you trying to figure out?
How much money?
How much money? Okay. So setting this up, you're actually going to use two variables. Okay. The first one we know we're going to have to use is D in dollars. Okay. We know we're trying to figure out how much he would make for D dollars. Okay. Well, what do we know from what they told us? How much does he get per car? $5. Okay. Here's the part where you would have to know that I have to use two variables. Do we know how many cars he washes? No. So we have to figure out another way to represent cars. Okay. Yeah, it could be X, it could be C, it could be whatever you want to. We'll use X here because that's what somebody said first. Was that you, Gavin? No, oh, there we go. Okay. All right. So, that was Oscar. Yeah, you see what I did right there? I had to get a second to think. All right. So, to set this up, we know to earn D dollars, he would have to wash X amount of cars. So, how you would set this up is D is equal to 5 times X. Because to get to that certain amount, it would be 5 times whatever that amount is. 5 times. All right. Any questions with any of those? All right. Well, let's keep going. Let's keep plugging along. Okay. Here is your next one. To evaluate an expression is to find its value. All right. To evaluate it, an algebraic expression, you want to substitute in the variables, the numbers for the variables in the expression, and then simplify it. Okay? So, sometimes you're asked to evaluate something. Here's what you have to know here. Each of these letters represents a different number. So here in the directions, they tell us that M is 3, N is 2, and P is 9. So, as we look at these, instead of saying MN, we've actually got to plug it in and figure it out. All right? So we know that M is really 3. Y'all jumped ahead of me. And N is really 2. If you solve that, 3 times 2 is 6. Good job. All right. Same thing with this next one. They start with P, which is really 9, minus N, which is 2. 9 minus 2 is 7. All right. And then the last one, P divided by M, so it's really 9 divided by M, which is 3. Which gives you 3. Y'all got it? Okay? So that's what it means to evaluate. Okay? Now, right here, solve the equation and then check your answer. Okay? All right. Do you want me to leave you alone with this? Probably not, right? Okay, so I'm not going to. There are 2 different ways you can solve this. Okay? And it all comes down to, do you like fractions? Do you not like fractions? Do y'all like fractions? No. Okay. If you don't like fractions, generally the easiest thing to do is to get rid of them. Okay? So what is the denominator in all of these fractions? 16. In all of them except for which one? Z, which is really just Z over 1. Okay? Well, here's the easiest way to do it. If you want to get rid of a 16 on the bottom of your fraction, how do you do that? Okay. Well, a fraction, I heard somebody say divide, so let's start there. A fraction is essentially division. You're 100% correct. So now think about this. How do you undo dividing something? You multiply. So what you would have to do here to get rid of those 16s in the bottom is you would have to multiply everything by 16. Now, watch what happens. when you multiply something by what you're dividing it. Okay, so you see you got a 16 that's being divided and a 16 being multiplied. When that happens, they will actually cancel. And the same thing will happen to this one. They will cancel. This is the hardest one we'll see for a while. Okay? So, once that happens, you're left with 5 is equal to, now, does that 16 in the middle cancel out? No. So what's 16 times z? 16z minus 7. All right. Now, to solve this, what do you need to do?
Put the 7 on the other side.
Yeah, you need to get the z by itself. So the first thing you're going to do is add 7 to both sides. 12 is equal to 16z. Now, to undo multiplying by 16, you have to divide. So you get z is equal to 12 over 16. Now, can I be 100% honest with y'all? You will not see that answer on a multiple choice test. Because you can divide. Yes, everything, both of these are divisible by 4. So instead of saying divide, the other word you've probably heard is you can reduce. Same thing. So what happens is 4 goes into both of these. So if you go 12 divided by 4, you get 3. 16 divided by 4, you get 4. So your answer would be 3 over 4. Now, I'm going to be honest with you. 3 over 4 can also be written another way. And it's probably a way that y'all much prefer because you like to use a calculator. How else could you write that? 0.75. That would be correct. Okay? So all of those things are there. Okay? All right, so here you go, guys. Y'all should have worked this out. Let's take a look. So for example 9, they ask you to solve the equation and check your answer. So c divided by 8 equals 7. What should be going through your mind is, how do I undo dividing by 8 so I can get c by itself? Well, to undo that, you need to multiply. So once that happens, you get c is equal to 56. All right. Same thing here for example 10. All right. You are multiplying by 0.5, so you need to divide. Now, the key thing here with this one, when you have one positive and one negative number, your answer is going to be negative. All right. 10 divided by 0.5 should end up giving you negative 20. All right. Any questions on any of that? Going once, going twice. So, all right. Here is the last example to really kind of look at. Excuse me. All right. Solve the equation, and they have 5 over 6w is equal to negative 20. Okay. Now, before I show you how to solve this, a lot of you probably already know how. I want to actually rewrite how this looks. Okay. This helps me. It really helped me when I was y'all's age figuring this out. 5 over 6w is really 5w over 6. Is everybody okay with how that looks? So all I did was just take that and rewrite it so that the w's on top where it belongs. To me, that makes it a little bit easier because now I can look at, all right, well, how do I need to get rid of this? Well, the first thing I need to do is to get 5w by itself. Well, to do that, that means I have to undo dividing by 6, which means I need to multiply by 6. So 5W equals negative 120. And then to get W by itself, I would divide both sides by 5. W equals negative. What? Should be negative 24, right? Bam. Okay. All right. So what we are going to do now, I have a homework sheet for you. So I'm about to pass that out and we'll talk about what that looks like. Ready, set,